Hello, welcome. So today I'm going to be talking about U-substitution in calculus. So the idea of U-substitution actually comes from the chain rule. So U-substitution is the chain rule in reverse, and we'll talk about that right now. So recall the formula for the chain rule. So the chain rule says that if you have a composite function, so f of g of x, and you take the derivative, then the derivative of that composite function is the derivative of the outside evaluated at the inside multiplied by the derivative of the inside. And what we can do is we can kind of work this equation a little bit to get kind of an understanding of U-substitution. So because these two things are equal, then we can apply the same operation to both sides. In particular, we can apply the integral to both sides. So we can integrate both sides. And again, because this is equal to this, then the integral of the left-hand side is also equal to the integral of the right-hand side. And then recall that if you integrate the derivative of a function, so this is just the derivative of f of g of x, when you integrate the derivative of a function, you just get back the function. So the left-hand side is just going to be f of g of x plus c. And so that's what we get. And then the right-hand side, we're actually going to work with. So the right-hand side looks a little complicated. And so what we're going to do is we're going to change it around so that it actually looks less complicated, but it's going to be the same thing. Because the right-hand side, we have a function, and then we have another function on the inside, and then it's multiplied by another function. And so what we're going to do is we're just going to call kind of this g of x on the inside u, and then this g prime of x dx, that's going to be du. And so that's what we're going to do. So again, this g of x becomes a u, and then the g prime of x, that becomes du. So it looks a little different, but it's exactly the same. But then this is really helpful for us, because what we did was we took an integral that looked a little harder and changed it into one that looks a little easier, and we know how to actually compute, hopefully. And we'll do several examples of these to see this.